Hello, I'm Riccardo Giraldi, Creative Director at Microsoft, and I'm very excited to be here. And I'm especially excited by the fact that there is such a conference happening in Italy. I've been waiting for something like this for about 10 years. We've been in a lot of conferences around and down Europe, but something like this in Italy, I've never seen it before. So a big thanks to the organization for making this happen, because it's super nice. So today I'd like to share my experience, share a few thoughts about design and the future of human interaction, just a few thoughts about it. And what do? My goal is to invent a design solution that improves people's lives. I focus on user experience to inspire and enable desirable futures. That is what I do. And my adventure started in Pistoia. I grew up in Pistoia, studied design, I studied electronics. And about 10 years ago, I left my hometown and I started traveling. I followed my passion about design and innovation. So I moved to London first, and then I lived in Stockholm and New York. And I had the opportunity to work in some amazing companies like BeReal, Uni9. I started as developer and then moved back to design. And that was an amazing experience. At the time, we were doing mainly websites, application, installation, and we were trying to explore new ways to combine technology and storytelling to create a strong emotional connection. And just to give you an idea, I'm going to show you one of the projects that we used to do back in those days. This project is called The Experiment. It's something that we did at BeReal. It was a project for White & Kennedy and Honda. It was a very simple project. It was a physics-based game that you play on a browser. Just for fun. We used to do like hundreds of these, but this is one that is particularly nice. I would like to show you. So it's a simple game that you play on the browser and use the browser in a different way. So it's a puzzle game, and you are invited to experiment new solution to create a chain reaction and see what happens, just if you try. So that was fun. And back in those days, it was super fun because we worked on these crazy projects. Like in this case, we had 40 different objects, and everything reacted to everything. So we ended up having thousands of combinations, and we ended up burning everything and destroying everything that we had on set. And we also had the chicken. And a super nice thing is that also we had the chicken master. So when you have an animal on set, you also have someone who takes care of the animal for safety, etc. So this guy has the best job ever. He takes care of the chicken, tells you when to fly, when not to fly, what to do. Amazing. Anyway, I'm super interested in human-computer interaction. And something I noticed is that, this is maybe 6 years ago, a lot of the experiences, the digital experiences that we see happen within the margin of a screen. Pretty much everything. Whether you're watching a movie, you're playing a game, everything happens within the margin of the screen. And these experiences only use your sight and hearing. So they're audio and visual. You don't really use all your senses. Everything happens in here. You can look somewhere else, the experience is gone. So the emotional connection that you can create is kind of limited. So even if technology gave us so much, we kind of got used to the idea that everything happening here, and we kind of lost the richness of the real world around us, and also our ability to use, for example, our hands, or to understand space and move around, so to leverage our human capabilities. So with that in mind, I started some experiments to try to see if there are different ways for people to interact with technology. And I'm going to show you 3 projects, 2 experiments and a commercial one. And I'm going to tell you a bit more about those in a second. So the first one is called Mind-Scaletrix. So this is something, it started as a side project. It's something I did in London and combined a few of my passions from electronic programming and human-computer interaction. And basically, the concept was pretty simple. The idea is that you use your mind to control a car, a slot car, like the polysteel in Italian. And so the idea is that, hey, instead of interacting just with mouse and keyboard, how about we find a different way for technology to understand your intention and bring it back to the physical world. So we showed this at one of our parties, and there is this small device that reads your EEG on your skin, And the more you concentrate, and the quicker the car goes. And if you blink your eyes, there's a little boost. And that was super fun to see people interacting in a new way, just a way that they were not used to. So it was a little experiment, and it was really, really interesting to see. So it was a small Arduino connected to very simple electronic, but enabled people to try something they never tried before, and enable us to learn a lot out of it. We ended up building a larger truck for 4 people. Here was in America, so everything has to be bigger. And so I went to Omaha in Nebraska and worked with a guy that built these amazing trucks. And I had a lot of fun, electronics and so on. And we went to South by Southwest and let people use this truck and see 4 people playing together. And at the end, it was a great truck, a great experience, and people had a lot of fun trying something different and using technology in a different way, something that enabled them to experience something new, also the emotional connection. A little side story I want to share is that this is the guy that built the truck. And he's an amazing guy. He used to be a professional racer of slot cars, of polysteel. And he built the truck, and he really liked the idea. He tried, we played together, we did the mind control car, and it was super fun. But then he was not super impressed. He was like, yeah, it's pretty cool, but you should come and see how we play. So I went to his car club, and these are the type of trucks that they built. They're massive. They're incredible. And they use this type of cars to play. They're something I've never seen before. And he said, come and look. That's how we play. That's how we have fun. So here's a video.
Can you introduce me to what this is?
This is a Group 7 wing car.
Okay, let's
This
say.
pros race these in the United States. I used to be a pro, but not so much anymore.
Well, there's no way I can film it.
So there's 1.86
wow.
seconds.
But how do you film it? It's too quick.
You gotta. You should see with 6 of them on there. Fast?
Wow.
Yeah.
So anyway, he was not impressed at all. And it was a very interesting lesson learned for me, like, hey, technology per se doesn't necessarily, make an experience better. You need to understand what is the purpose for it. In this case, probably it doesn't make his experience better, but maybe for accessibility. Maybe there are a group of people that actually would really benefit from that technology to be able to control technology using their mind. Another project I want to show you is WebLab. This is another project we did with Be Real in London for Google in this case, with the Creative Lab and many other partners. And it was a 1-year exhibition at the Museum of Science of London. So we have the entire floor, and we had 5 installations that people could control online or at the museum. And it was a super interesting project where we had this amazing space. And the Museum of Science of London is amazing, and we had an entire floor in the basement. And visitors could go there and use these physical installations. We had an orchestra, we have some crazy stuff, and they could collaborate with people online. So what was interesting here was to start exploring how an experience can live out of the margin of a screen and connect people that are online and at the museum. So what does it mean to have a co-presence, for example? How does it feel to feel the presence of someone who is far away? But also problems such as when you're in the museum, you have a line in front of you of 10 people. What happens if you're in line and you have 1,000 people in front of you? How do you deal with that? So very interesting thinking about all these different problems. Thank you. So here is another R&D project we developed at Be Real. In this case, this project is called ILS. It's another exploration, is the same theme of bringing experiences back to the good old tangible world. So to have experiences that happen beyond the margin of a screen. And also experiences that involve more of your senses. So it's an installation, and there were 2 projectors. It's a 3D interactive 3D projection mapping interactive installation, let's say. Up to 8 players can play together using their phone, and they can play a game that, imagine being like Snake, but on a physical installation. And that was quite interesting, because usually we play all digital experiences on a flat surface. That's what we're used to. Usually it's a rectangular, flat surface. But what happens instead if you play an experience in the real world, mapped to the real world? So what happens in this case is that you also have to move around. You have to dodge other people, you have to evaluate distances, and that's interesting. It's a different way of thinking about digital experiences and the power of digital experiences projected in the real world. So, yeah. Then what happened? Let's fast forward a few years. I moved to New York. I work in products. I moved from advertisement and campaigns to products. I was very passionate about the idea to create something that people will keep on using and improve their lives. Campaigns were fun, but I wanted to have something with more purpose. And so I moved to New York, worked on a startup about travel called Escape Flight. It was a super fun experience. And then at a certain point, I received a call from Microsoft. And at the beginning, I didn't know much about Redmond, which is in Seattle, close to Seattle in the Pacific Northwest in the US. I didn't even know where Seattle is in the map. So I was like, oh, I don't know. And then I went there, did an interview, I talked to the team, and I met some amazing people. And I realized that they were working on something pretty interesting. So what I do today is, today I lead an incubation team at Microsoft. We are about 40 people from all around the world, multidisciplinary team. And what we do, we inspire, prove, and enable transformative user experiences that push and define new devices and platforms. So that means that we are an incubation team. So we start with research, ideation, prototyping, and then storytell new ideas to come up with new form factors, new devices, new applications. It's a very interesting experience. But when I joined 3 years ago, I moved to Seattle to work on this secret project. And this project is HoloLens. And from a human-computer interaction, from a design perspective, that was a dream. It's everything I wanted to work on. It's like thinking about new ways to create experiences that bring the benefits of digital and the benefits of the real world together. Bring basically all the things that we cannot renounce, that we love about computers and technology, but back to the real world. And so, yeah, I've been working on this project for 3 years, and maybe it's a one-in-a-lifetime opportunity to work on something like this. So let's talk about it for a second. How many of you know HoloLens? That's pretty good. Okay, okay, but for all the others, to give a little bit of context, I'm going to play the video that we first released when we announced the product in January 2015.
Look around. Technology is all around us. We use it in every aspect of our lives. It enables us to do amazing things. But what if we could go further? What if we could go beyond the screen? Where your digital world is blended with your real world. Now we can. This is the world with holograms. What will they enable us to do? New ways to visualize our work.
I have an idea for the fuel tank.
New ways to share ideas with each other.
How are things going your end?
I just put the images in OneDrive.
Perfect.
More immersive ways to play. New ways to teach and learn.
So put the new trap in the place of the old one.
Now what?
And tighten here and here.
New ways to collaborate and explore the places we've never been.
Look at this formation. Let's take a closer look.
And new ways to create the things we imagine. you change the way you see the world, you can change the world you see. This is Microsoft HoloLens.
So, HoloLens embraces physical reality and content and virtual content and to create a new reality. And that's what we call mixed reality. Mixed reality is the blending of these two words. So you can actually have holograms integrated in the space where they matter the most. So it's different from VR as we know it today. Mixed reality is basically embrace both. HoloLens in particular start from reality rather than occluding it. If you think about virtual reality devices, you are immersed in a completely new world. The reality around you disappears. With HoloLens, you start with the reality, and then you can decide how much digital content you want. So let's start with some of the advanced technologies, and then I'll talk more about the design component of it, what I think is most interesting from an interaction perspective. So HoloLens is the first fully anti-holographic device, enabling high-definition holograms to be integrated in your space. So basically, you don't need another computer. That's the computer. That's all you need. You don't need a phone. You don't need any cable. That's all you need. Everything happens here. It's a lightweight device that you wear. And let's have a peek inside. So it has many sensors. These advanced sensors that scan the space around you and enable you to basically have awareness of the device, to have awareness of the space, have awareness of you, and enable you to interact in natural ways using what we call GGV, gesture, gaze, and voice. And we will talk more about this in a second. It has transparent lenses that let you see through, so you can see the real world, but also you can see holograms integrated in it. And it has a new type of processor. We call it HPU. It's the holographic processing unit that enables this small device to process all this data and in real time integrate holograms in a way that we say it's word locked. So it's an hologram that is there in space and actually stays there where you place it. It also has a very unique sound system. So similarly to the see-through lenses, you want to start from reality. You don't want reality to be occluded in any way. So the speakers are actually the small orange items placed right above your ears. So you can still hear the sound from the real world, but then it can be announced by the digital experience. And what's more interesting is that we are using a technology called HRTF, or binaural sound. I don't know if any of you is familiar with this, but it's pretty amazing. Basically, what happens is that you don't just hear stereo sound. You hear 3D sound in a way. You can actually tell exactly where the sound comes from. So when you see an hologram right here, you can hear the sound coming exactly from the spot. If it's behind you, you can tell exactly where the sounds come from. I'll talk more about this in a second. All this technology enable you to see holograms. So like objects made of light that you can place in the real world. And you can see this object from any point. These are, imagine them being like objects. You can walk around, they're 3D, etc. And what's interesting is that you can actually place them as if you had world coordinates. So you can actually place them somewhere in the real world, and there they will stay. So you can move around, and they actually stay there integrated, and that's amazing. There's also a new way to interact. So how do you interact with holograms? What do you do? There's something that we call GGV. Thanks to these sensors, thanks to the cameras looking in front of you, you can use gestures. Thanks to microphones pointing at your mouth, you can use voice. Thanks to sensors in the device, you can use gaze. So let's have a look at what these interactions are. So gaze means that the device is aware of what you're looking at. Not your eyes, but imagine having a laser pointer vector coming out of your nose, and as I move my head, the device knows what I'm looking at. So I can, for example, look at a person, I can look at Filippo, and say something to interact. I can click on Filippo. So the device knows what I'm looking at. And it's quite fascinating because, even from a designer perspective, imagine having to design what the cursor looks like in mixed reality. No one has done it before. So it's like, or at least I imagine it being like when they invented the computer and they have to think about the mouse and the cursor. What's the interface? No one did it before. So that is super fascinating, exploring, a new language that didn't exist before. And once you look at something, you can use gestures or voice to interact. So gestures, think about it like the mouse click, in a way, in its simplest form. So there are a number of gestures that are recognized, but I can look at something and select it. You look at an holograms and move it around. That's how you can interact. You don't need any other device. You just need your hands. And then you have voice. So the device understands you. You can look at something and say something. So you can look at something and say, take a photo. Or you can look at something and select it, and so on. There are a number of voice commands. And another technology that I find super fascinating that enables a lot of the scenarios that we'll see in a moment is spatial mapping. So all these different cameras around the device are scanning the space around you in real time. And that's quite fascinating. Basically, the device creates a mesh of the environment around you. Imagine actually having a mesh, little mesh of the surfaces around you. And that is quite unique. It can enable some very interesting scenarios. So let's have a look at a few. This is actually an experience that we developed. And thanks to spatial mapping, you can actually have digital content that are aware of your environment. So you can use in many different ways. Occlusion, for example. If an hologram goes behind a surface, you want to be able to occlude it. So you actually understand that it's hidden. Or you can use, for example, for navigation, so that an hologram, a character, can walk around your space. Actually, even know that that is a sofa. So when it bounces on the sofa, it bounces higher. That's amazing. You can use for physics. You can have elements that bounce around. For placement, I want to place something in the wall. I don't want it to go inside the wall. Or for visualization. Maybe you just want to have an application that requires you to better see the surfaces. So with mixed reality, what happens is that you can basically choose how much digital content you want. You can have the physical world as it is, the real world, without any abstraction. And you can just interact with the people around you. You are free to move in space. There's no mobility concerns. Or you can add digital content, integrate it up to a point that becomes virtual reality. So talking about spatial sound. Spatial sound is actually a very important component. Often we forget about sound, and we talk a lot about just about the visuals. But sound in space is extremely meaningful. So what happened is that we use this scientific model that basically understands how human perceive sound, depending on the difference of how the sound arrives at your different ears, to recreate, basically, to enable developers to position sounds in space. So let's have a look at an experience where this is particularly important. This is called Roboraid. It's the first mixed reality, first-person shooter, where you can defend your home from a robot invasion. It's a very fun game, and aliens actually come out of your walls, and that's pretty cool. And you can use natural movement to target enemies, so use GGV, and to strike back. And what happens is that spatial sound is super important here because maybe there is an hologram that is behind you. And the fact that the sound comes exactly from the position, it means that you can easily identify and attack back. And we talk more about Roboraid a little bit later. So let's look at some of the experiences that are enabled. So thanks to spatial mapping, so the understanding of the space, etc., and the world coordinates, so the ability to have an hologram that actually is locked in the real world, you can create holograms that you believe they belong to the space, so they're legit. In the moment that you have a content that, for example, is on a screen, your reaction to it is very different. You don't really, you think about it as a virtual object in a screen. But when you see something that is integrated in the space, you start leveraging all those human capabilities that we develop throughout our evolution of understanding spaces, distances, the sense of presence, and so on. So one example is the true scale. So you can, as you have an object in the screen, you can't really tell how big it is. In the moment that you see there in the physical space, you can actually compare it with the objects around you and understand how big it is for real. Imagine seeing a dinosaur, how massive it is. When you see it on a screen, it will never be the same. It's not the same. But in this case, you can actually see the true size. You can actually move close to it, etc. In this case, imagine that you're buying from a catalog of IKEA, and you can actually preview how something looks in your space before you buy. Imagine that. Or spatial memory. By being able to place hologram in space, you can actually tap in the spatial memory, our ability to remember things in space. So there is a persistency of holograms. It means that you leave an hologram somewhere, it stays there for you to go back later, if you want. And also there is an amazing sense of presence of the hologram. And this is so fascinating. So basically, imagine seeing a content, something that maybe is a famous person, maybe is one of your favorite characters, and you see it on TV or on a screen. It's interesting. In the moment that you see it in your living room, sitting on your sofa, that's amazing. It's totally amazing. So because this character is actually in your room and is aware of your space, can walk around the table, can look at the sofa, can decide to sit on your sofa, can look at you as you move around, and that feels incredible and enables some very interesting scenarios from education to entertainment. It's just fantastic. I'll show you. Let's see if I have it. I'm not going to show it. So this experience is called Fragment. So is an adventure that you play where you have characters coming directly in your space. So in virtual reality, you are usually immersed in a different place. So you go somewhere else. There's an incredible sense of presence of you being somewhere else. With mixed reality, you can do that, but you can also bring the experience to your space. So the device is aware of you, of your space, but also aware of where you are in your space. And it has a camera here in front that enable the device to see from your perspective. This is a very different type of relationship that you have with technology. Usually you look at the screen, and the screen look at you. In this case, the device is looking at the world from your perspective. What can you do with that? You can, for example, enable other people, remote participants, to see the world from your perspective and help you. So imagine having an expert that remotely help you to solve something. Maybe there is a doctor and need help, and there is an expert that is actually telling you exactly what to do. Not only can see from your world, but can actually draw in mixed reality. So can actually draw content in the space, and the content will actually remain integrated. There are also many interesting opportunities when it comes to learning. So being able to see 3D content in 3D, collaborate with others, and being able to see what before was not possible, especially at true scale. It can also extend your tools. So, you can still use your computer and use your applications, but sometimes especially when you work in 3D and you see everything on a 2D screen, you have to do the leap of imagination of, hey, I wonder how it's going to be later on. But now you can actually extend the experience and have that experience, come to life in HoloLens. So you have a society of devices that work together to enhance your work. You can also have new ways to play and use the environment as your interface. This is super interesting. Think about being able to play a game, and you can move the table to help your character jump from the sofa to the other side of the room. Think about using the physical objects as an interface that you can move around. It can also make the invisible data of the world visible. That means that you can actually augment your senses and see things that otherwise you wouldn't be able to see. Let's say that you are in a manufacturing lane and you need to know if a surface is too hot or not. And maybe there are sensors, and you can see that information being mapped in the wall. You can actually see, hey, it's too hot there. I'm not going to touch it. You can also preview your work, better understand how things work. Think again about the IoT, like having all the IoT data integrated with you. Or think about scenarios in which maybe what you do, you're doing training, and you need to have instructions integrated in the space. So that means that you are trying to learn something new, and instead of looking at some paper and then trying to understand the schematic and applying it to the real world, you can actually see the instructions integrated directly in the space, or having a remote participant telling you exactly what to do. I'm going to show you another experience. And this shows a new way to collaborate with remote participants and a new way to explore together. This is called On-Site, something that we did for JPL at NASA. Let me show you the video.
On-Site is a tool we're building in collaboration with Microsoft to connect scientists and engineers with the environment of the Curiosity Mars rover. Since we can't put our scientists yet physically on Mars, a technology like this allows us to investigate, well, what's possible if we can make them virtually present?
This was the first time where I could basically do a 360 and see Mars all around me.
I love the fact that people, when they first encounter this project, have a feeling of, wow, I've lived to see this.
Instead of looking at 2D images, they can now walk around and explore Mars in their office.
It was part inspiring and part just like, wow, I can finally do this thing that I really want to do. I could see using this every single day.
It is a different way of exploring. That's transformational. Our plan is to deploy on-site to mission operations this summer and to be controlling rovers on Mars with this technology in July.
All right. I was bowling, so I change. So this is a very interesting experience. So basically what happened is that this is actually a real experience that we did in collaboration with JPL. And what it does, it helps scientists study the surface of Mars. So there is a Curiosity rover on Mars, it's sending images. And scientists were studying the geology of Mars and the terrain on a screen. So there is an application that they are used to use, and they know how to use very well, it functions very well. And so we didn't want to change that, but we wanted to augment that experience. So what happens is that you can still use that application, you can wear HoloLens, and then you can decide where to place Mars. So you can say, here's my computer. You keep on seeing your computer, the mouse and everything. And then you say, I want Mars here. So you can work, and then you can stand up, walk on the surface of Mars, collaborate with others, and then go back to your computer if you want to. And the integration is such so that you can actually take the cursor of the mouse and move it out of the screen, and it goes in 3D. So I find that very, very interesting. There are new ways to build, and imagine being able to build 3D in 3D, and how more accessible that could be. Or get assistance remotely, collaborate with others, or finding new ways to play together. Or, tell interactive stories using your space. So there are many different opportunities, and I'm personally extremely, extremely excited, especially seeing now developers working on it and coming up with new ideas and new uses for it. I think that this is one of the projects that can change computing and can change our relationship with technology in a very big way. So I'm going to play another video, and this shows some of the applications that we did with some of our partners, our commercial partners. All right. So something I find extremely fascinating is that as a designer, designing for mixed reality is a completely different story. So usually what happens is that as a designer, you design applications for computers. And computers speak a language that is not this language that we usually speak to each other. So it's a language made of icons and feedback. And it's something that we had to adapt to. We have to learn what a feedback means, what an icon means. In this case, we can use the language of the real world. And that's extremely fascinating. It also means that there are other type of designers that now are very well equipped to design these experiences. So think about an architect that knows how people live a space, how to design a space. Think about a game designer that is used to do 3D interactive content. I find it extremely fascinating. We have a team where people come really from different industries. There is a friend who works at Pixar as an animator. There's a person that works as an engineer at NASA. We have all these different people working together, and everybody's bringing something different to the table. And at the same time, it's so easy. You can just make an object, and you realize that everything that you know about the real world applies to these experiences. And also, we got to send the HoloLens on space, so I can tell my mom that now one of the things we did is on space. And that was pretty cool. And also, they got to play the Robo-Raid on the International Space Station, which is strange. And so I believe that mixed reality, can really change the way we interact with digital content, and the way we connect with others remotely, and the way that we see the world. And what's interesting is that HoloLens see the world from your perspective. It's aware of your space, and thanks to contextual understanding, can reduce the time between intention and action. So the relationship really is changing, and that's the third part of the presentation that hopefully in 9 minutes and 12 seconds I will go through. So I speak fast. I'm really fascinated about how the relationship with technology is changing, the relationship between human and technology. We are moving away from a world where people must understand technology, computers, to a world in which computers understand us. And that's a big change. It's a big, milestone in our relationship with technology. So technology is not just a simple tool anymore. It's something that is capable of incredible things. And let's go back in time and let's see how this relationship evolved, because I really believe that this is the next big thing to think about as designer. So as humans, we are tool builders. That's what we do. That's what makes us different from everybody else. And we have this incredible gift, which is imagination. Imagination allows us to escape the current time and place or perspective. So we can imagine things that do not exist. And this is something that sounds obvious, but thanks to our prefrontal cortex, we can imagine something that is totally new, it's totally novel. So the imagination fuels creativity that opens the door to innovation. And since the very beginning, as humans, we invented tools to solve our basic needs. So we started with, weapons to hunt for food, and then we learned how to make a fire to stay warm and cook our food. We made clothes, built boats and houses, and we are amazing sometimes. And this new technology helped us to satisfy our most basic needs and physiological needs to survive. But then, we also kept on optimizing this. We didn't just leave them there. We actually kept making improvement. But not only that, we did not stop there. We constantly explore new ways to enhance our human capabilities and improve our lives. Writing allows us to communicate to distant lands and capture thoughts and memories that could last forever. And we did telescopes to look further. What kind of needs did that solve? Definitely not a primary needs. Our desire to achieve more push us to where we are here today. So we developed technologies to satisfy our basic needs. We were able to move to higher level needs, right? So we built a new technology. We were safe, we could get food and so on. And then we optimize it so we could spend more time thinking about other problems that were more important at the time because some were solved. Now, unfortunately, we know that the Maslow hierarchy of needs is wrong. That's been proved to be wrong because there's no Wi-Fi. So that's important. Anyway, so it's interesting also how our mind imagines something that is totally disruptive. Didn't just find another solution, sometimes totally change the way that we think about a problem. Think about moving to find food. So what do we did shoes, and then we learned how to ride horses. We did some incredible things. Then we invented a car. That's amazing. It's a big jump. People would have not thought about that, but we actually came up with some crazy solution that's disrupting innovation. But no solution comes for free. Every solution is basically transforming a problem into something else. So we went from a horse to the car, and that totally improved is a way better solution. Introduce other problems, pollution, traffic, many things. People that die because they drink and drive and tax. So there are other consequences to the solution that we have. And I find super fun the fact that we went from horses to car, and now we are trying to do a car that is at least as smart as a horse, so that it doesn't crash the wall, it's self-driving, doesn't pollute, you can whistle and come to you. I love it. So as we develop more complex technologies, these technologies require more attention. So we kind of got stuck with some of these technologies because sometimes, especially recent technology, it takes some time to optimize them up to a point so that we don't have to think about those. And I like to make this analogy with the camera. When we invented the camera, we didn't actually invent the photo camera first. We invented basically it was a tent at the end of the day. And it was a camera obscura. And you will go inside the tent to make the technology work. So the technology was not very mature, so it needed human to make it function. And over time, so what happened, you had a small hole, and then what happens is that the image was reflected, and people will actually painting the reflection of the image to actually make a painting. And then we moved away from it. So the human came out of the camera, and then the camera all of a sudden adapted to our needs. So instead of being us adapting to technology and spending time to take care of technology, the technology became mature enough so that we could eventually make it more natural for us, adapt to our needs. The same thing happened with computers. Ada Lovelace is considered the first programmer ever. She's a woman, and not many people know about that the first programmer was a woman. And she wrote a lot of notes about the analytical engine. And what she noticed is that the computer was capable, or the analytical engine was capable of whatever, as soon as we know exactly what to tell it. So it was not very independent, required a lot of instruction to do anything. You needed to input everything. So a similar process to the photo camera happened. Before it needed a lot of attention, human made it function. Then computers were as big as a room, and then became shrink, and then a laptop, and then a mobile, and then we were computers. Super fascinating. So computers are a tool for our minds. Steve Jobs actually called it the bicycle of the mind. It's a super fascinating, beautiful image. But what happened is that digital technology is so important that it's in the very fabric of our society now. It changed all aspects of our life. We find a job, we are good at our job, we meet people, dating, everything. You pretty much need to know a computer. Being literate today is not just about writing and reading, it's also about knowing how to use a computer. But what happened is that computers are still quite new, if you think about that. They're quite new, so still require a lot of attention. It's changing, but still require a lot of attention. You need to charge the phone, you need to update it, they're still kind of babies, they're pretty new. Eventually, we will want to spend less time with it. We will want to make these devices more independent. We are at the point where, even if technology starts understanding us with, natural user interaction, with sensors and so on, what happens is that still, we adapt our behavior to it. Sometimes we speak a little bit slower so that Siri, Cortana, Alexa will understand us. That still happens. So we are still adapting. We are treating it as a kid maybe, or something that is not mature yet. But something is changing. Now we have machine learning. Machine learning can totally change our relationship with computers, can actually give computer the ability to learn without being explicitly programmed. So it's maturity of computing. So they use big data to learn, and then are able to recognize and process new input. And it's amazing. Somehow it works. And you do some training, you give big data, and then they're actually able to understand with very high level of confidence what this new input is. And this applies to speech, is applied to images, pattern recognition. There are so many things. It can recognize body parts, it can recognize objects. Think about self-driving cars is everywhere. It's improving many aspects of our life. Sometimes I get it wrong. So this is a panda, and I love it because it's like sometimes, where is it? It's a custard apple. It could be, maybe, to a certain degree. And sometimes see the word in a way that we don't really say. So with super high accuracy, we'll tell you that that is a starfish. 99% sure it's definitely a starfish. Or, that is totally remote control. You can kind of understand why it sees the word that way, but look at this one. This is definitely a robin. So it's still early days, but it's getting there where it's actually understanding us. So much that last week, a group at Microsoft Research announced that now computers are able to understand speech at parity level with human. That's amazing. A computer can understand human speaking as well as other humans. That's amazing. So we are moving from a world where humans are experts of can I go a little bit over? Thank you. Sorry. So we are going from a world where we are experts of computers, so we are digital literate, to human literate computers. So computers that understand us. That's amazing. Think about it for a second. So the relationship is now balanced. So, but understanding us is not enough. We are complex beings. Not only you need to understand what we say, you also need to be able to interact in a social context. You know, you want to be able to have a computer that interrupts at the right moment. You want to be to have a computer that knows how to behave in society. You don't want to have a computer that stops listening to you. You talk and stop listening. You don't want to have a computer that you interact and is thinking about something else, is loading something else. You know, it has to evolve. So eventually, the real change is for technology is when it starts to become proactive. Understand when to act. And we need to talk about self-driving cars because that is amazing. You know, think about it. It's better than human. It's safer than humans. This is disrupting innovation. It's amazing. You could think about, you could solve many of the problems that we see today. You can solve, for example, the problem of people driving while, you know, drinking. You can solve it in many ways. You can put a sign, you can put police, you can educate people, or you make the car that drives by itself. It's amazing. It's incredible what it can do. So, but what happens is that with great powers come great responsibility, right? So we need to be, you know, there's so much. It's super exciting now because, you know, these devices learn. And we need to understand who is teaching them and what do we teach them. So when you drive, you have to take decisions at the last minute. Maybe something goes wrong and you need to decide what to do. What if you have to educate a car on what to do in extreme situations? So the MIT did this website called The Moral Machine, where basically ask you the question, so what should the car do? So this is a situation, there is a, you know, there's a problem with the brakes, and the car has to decide, what do? Do I go straight and eventually kill these people, a baby and an old man? They were, by the way, you know, going, you know, there was a red light, or should I kill animals? You know, we don't think about that. Usually, you know, it just happen. A person last moment decided, and, you know, that just will happen. But someone has to program it, and someone has to say, yes, that's the law, that's fine. Let's look at another one. What do we do? I guess that everybody agree on what happens, right? But sometimes it's not that easy. Sometimes it can be hard, you know, based on what do you decide? I don't know. It's fascinating, no? Shall I kill the doctor, the successful doctor and the beautiful woman, or the thief and the poor man? I mean, I know, but I have my opinion. Do we all agree? Probably not. So one more. What to do? What to do? You know, this guy is the answer. He says, you know, dogs are breaking the law, first of all. You know, this was a red light, so that's a good, you know, it's a good sign. But also, cats have 9 lives. So maybe, you know. And this kind of thing, because basically, you have to think about yourself. It's kind of a mirror for yourself. You feel like, so what do I really think? What do we as society agree? And at the end, in this website that I totally encourage you to go and see, actually show you what was important for you. So was it more important for you to save more lives? For me, it mattered a lot. That's an average. Was it important protecting the passenger? I was like, maybe not. Upholding the law? Or, you know, does it matter to intervene? Or gender, which one do you prefer? It's fascinating. We don't think about that, but we have to agree. If we want to give responsibility to another entity, to technology to be independent and take decisions, and that's happening today, we have to agree. We have to come up with something. So I find this super fascinating. Like, you can think that artificial intelligence, machine learning can, you know, learn faster, can share immediately, and there are thousands of cars, millions of cars around, so it can learn instantly, can share their learnings, and will never forget. So in a way, they're better than human, and that's fascinating, but is it? So another aspect where, as human, we know that we are really good, but now machine learning is changing our perspective, is art. So there are many of this website. You upload an image, choose a style from a famous painting, and thanks to pattern recognition and so on, will transform your image into something else. So I tried. So let's see what happens. That's it. Let's try another one. That's a motorbike. That's me motorbike. Let's try another one. I try with the digital word, with the DDD. That's me. But look at this one. That's amazing. You know, it's amazing. That's a computer. They just learn it, and now that they learn, it can do it more and more. So it's interesting. You kind of wonder, what is the role of human at this point, right? And it's up to us to decide. Probably our role will become to teach, to decide what we want to teach, what kind of future do we want to have. With all these possibilities, we have the responsibility to be careful in what we teach them. There are a couple of examples I want to mention. One is about something that usually we consider objective, which is data. So machine learning uses a lot of data. So something you may not have thought is that data can be exclusive too. So Beauty AI was a beauty contest AI, and that was found to be biased against people with dark skin. And that's very interesting. Despite the fact that the objective measures were used in the algorithm, the training data set itself was biased and led to a biased conclusion. So unfair judging of beauty contests may not seem like a big deal, but you know, it is a big deal. It is a big deal. Because of the data that we had, that's what the artificial intelligence learned. It's like growing up a baby. You know, depending on what you teach it, we learn different things. So this doesn't seem too bad, but think about what if an artificial intelligence will put someone in jail? So do you remember Minority Report? And we had a pre-crime. So it has become real to a certain degree. So there are now forecasting algorithms that judge how likely it is for a person to be charged with a crime, to commit another crime in the future, which can affect the sentences. So research showed that these systems have a bias against blacks, again. So for example, in this picture, both of these people committed a small theft, but upon booking, the woman on the right was rated high risk. However, 2 years later, she had committed no future crime, while the low-risk man next to her has committed another more serious crime and is serving 8 years for it. So it's fascinating. And these go back to what is the role of design. And there are all these amazing opportunities, and there are so many things happening, and I find it super fascinating that what remains to be the most important thing is our imagination and our creativity. So more and more, the role of designer, of imagining a desirable future that we want to live in, is important. We need to think about these issues. We need to think about how to use tools in a way that improve our lives. And it's normal for every generation to be scared to a certain degree to new technology. People thought that writing was evil. Books, let's burn books. Photos will steal your soul. It's normal. You know, it's just a generational thing. I'll probably be super grumpy in a few years and hate all the new tools that, you know, kids will play with. But it's an opportunity. We have the opportunity and responsibility to design a future, imagine and have a vision for a design that we want to live in, and make this tool better. It's up to us. Otherwise, I mean, who is going to do it? So it's really up to us. So Steve Jobs described the computer as the bicycle for the mind. Now we made the self-driving bicycle. That's interesting. So what is the motorcycle for the mind? What are we going to do next? Can we have artificial intelligence that make us smarter? Can I brainstorm with an artificial intelligence? Can we build tools that keep on improving our lives, and instead of finding a role for humans on something that we really want to keep for ourselves? So anyway, many open questions, many thoughts, and I find it very, very interesting. I'm going to leave you today with some books that I love. I always like to end presentation sharing some books, and I would love to hear what are the books that you guys love. So I'm going to share this free. I wanted to share thousands, but here are free. So one is The Power of Habit. It talks about how habits in our minds are formed and how our life is ruled by habits. It's super fascinating. It describes habits as shortcuts that our brain makes to cope with new inputs and not overheat as if we were a computer. Super fascinating. Creativity.inc from Ed Catmull, the founder of Pixar, talks from how he made Toy Story to thinking about how to create environments that foster creativity and help everybody to express their full potential. Super good. And then, oops, no, too early. And then Michio Kaku, which is a very interesting dude, talking about the future of the mind and what our mind is capable of, all very recommended. I'm out of time. Thank you very much.